Alright, so today we're going to talk about notations, or how we represent different values. Actually a specific kind of value. Now I think at this time in your career, having gone through as much school as you have, you've got the idea of counting down. So if I send you outside and ask you how many kids are playing out in the yard, you can come back and say, Mr. Linder, there are 12 kids playing in the backyard. And some of you might even be a little bit more specific and say there are 6 boys, 6 girls. All of that is correct. You're using numbers to represent a value. Now, you've probably already got measuring down pretty good too. I know we've had a lot of worksheets with that. So if I go out and say, how tall is that house over there? You guys can come back and say, Mr. Linder, it's 18.5 feet tall. At which time I'll say, what were you doing up on that ladder? You guys are going to get me fired when your parents find out about this, but that has nothing to do with what we're talking about today, because you'd be right. We're saying a relational value of feet to the size of the house. All that's pretty easy, and that's kind of what we do instinctively. We like to say, like, oh, I have 3 fingers, and I can graphically represent this, or I can write the number 3. Just the way our mind works. It's easier to grasp concepts that way. Today we're going to be talking about a different kind of value. So, can anyone tell me what a fraction is? We've done these a lot. What's a fraction?
It's a part of something?
It's a part of something. That's a very good way to say it. It's a part of something. So if I have a fraction of something, I have a part of that. Let's be a little bit more specific. How would I represent a fraction? Like, here's a pencil, right? So I break it like this. This is now a part of the original pencil, right? How would I write that over here if I wanted to write it as a fraction? How would I write that?
1/2.
1/2. It is indeed 1/2. More specifically, we have a value with a numerator and a denominator that says this is 1/2. Does everybody agree that I wrote 1/2 here? So who can tell me what the denominator represents? What is that?
The whole number?
Is it the whole number?
The
It does.
possibility
You are
maybe?
correct. It is represent the whole of what we're measuring. And it not only represents the whole of what we're measuring, but what type of pieces we've broken it up into. So there are 2 possible pieces in the whole. That's why it's a half. So if I put it back together, this is the whole, and this is the half. If I break both of these again, I would have 4 pieces. So we were talking about groups of 4. That's correct. And the number on top, what does it represent?
The number of pieces you have.
Right, the number of pieces I have from that whole. So this would represent one of my halves that together make a whole. I think everybody's got that concept down pretty well. So if I wanted to write 1/2 as a percentage, i.e., what is this percentage of the whole, how would I write that down?
But how much out of 100?
How much about 100? Very good. I like it. I like it that you phrased it that way. So a percentage is, as you said earlier, part of a whole, just like a fraction. However, it's always parts of a whole. So we represent it as the number of parts of the whole, and then we use this little symbol here to mean that's percentage. All right? So this is 50 parts of 100. So I have a question for you. What would be that, excuse me, losing my board here, as a literal fraction? So percentage of 50%, how would that break out to as a fraction?
1/2.
1/2. It is indeed a value of 1/2. But when we say 50 parts of 100, how would I write that as a fraction?
50 over 100.
Right. This is also 50 over 100, which you have learned from many, many, many worksheets on Friday afternoons to convert down to 1/2. Now, human beings like to count things. We like to represent them as a value. This goes back to putting everything down to like the number of fingers. I have 4 of these and I have 3 of these. Problem is, it's not too easy to graphically represent 3.5 fingers. It just doesn't work too well. But there is a way of converting it into the same type of notation. You guys remember our number lines that we spent a lot of times with, and there was always a 1's value, a 10's value, and a 100's value, correct? This makes math really easy. So instead of using symbols or X's and V's like in Roman numerals, we use that slotted decimal notation, and it makes math much easier to do. You can do the same with these. So this is 50 parts of 100, right? So how many tens part of 100 is it? 5. So that's 5 tens parts of 100. And how many ones part of 100?
0.
0. And how many hundreds part of 100s?
Half.
True, but actually none that actually would go in our number line. That is actually a pretty good point. So when we're doing a decimal, what we do is we start off with a 0 just to make everything confusing. And then we put in a decimal so we can use our tens and our hundreds and our thousands places and do math just like if we were going to the other part of the scale. So my 50% is 0.50 if I write as a decimal, which allows me to then do math and all that stuff much easier. Now I know what you're all thinking right now. And what you're thinking is, in 15 minutes it's lunchtime, so you better wrap up quick. But what you should be thinking is, why would we want to do this? And people actually struggled with this for a very long time. Not the why of what they wanted to do it, but the actual problem. There's lots and lots of people who are able to come in and say, I have 5 things. Well, that's great, until you need to start dividing them up amongst people. So back in the old days, when people used to hunt for a living, people would go out and hunt, and they'd bring back food, and they had to divide it evenly and fairly among the groups. So kind of like when you guys are kids and you're arguing about, Mom, his piece is bigger than mine, or she got more than I did. And your mom would very diplomatically say, shut up. However, if she knew math, she would be able to use fractions or decimals to divide it up evenly and explain it to you. Now everyone can sort of understand that. You've all been sitting around dividing up food or toys and deciding who gets what part. But the ideas of fractions actually came out of something else. In business, and especially in insurance or investing, people would often have to gather a bunch of people's money together to make something happen. So if I'm planning a colonization of the New World, I'm going to take a group of people to America and we're going to build a colony. I got to get somebody to pay for all that. And they're going to want to get that money back. Or more importantly, they're going to want us to make a profit, and they want to get their money and the profit back. So I have to start deciding, well, Bob gave me this much money, John gave me this much money, and Ralph gave me this much money. That's not very convenient to just pull out of the air. However, if John gives me a third, Bob gives me a third, and Ralph gives me a third, and then I come back and say, here's your original money, plus we made 15 extra dollars, I can then divide that evenly as well. And it's actually that in insurance which led to a lot of our modern math today. I know, however, you guys could care less about that kind of thing. So, Miss Devon is going to help me with a little experiment so I can show you how we actually use this kind of math. In here, I have sweet tarts. And there are 100 sweet tarts in here. I know it's hard to believe because it's a very small amount. But trust me, there are 100 sweet tarts in here. I want you to come up and help me out. Come here. My favorite are the green ones. Can you tell me how many are green? No, you're not allowed. Just can you tell me how many are green?
No.
Okay. Well, that's a good point. If you have, I think you've been messing with my sweet tarts. Go ahead and count out how many green sweet tarts they are and put them in this bowl so we can separate them out.
I can't.
Whichever way is easier for you. And don't eat any of them. Oops, that one doesn't look green.
No.
I know.
20.
20. Okay, thank you very much. You may sit down and leave the delicious sweet tarts with me. We'll divide them up later, don't worry. So there are 20 green sweet tarts. So if I'm trying to decide how many of the whole group of sweet tarts are green, how would I represent that over here? Let's start with a fraction. I've already decided a fraction has a numerator and a denominator. What should those values be in my fraction?
20 over 100?
20 over 100. Sounds suspiciously correct. But why? Why 100?
Because there's 100 sweet tarts total and 20 of them are green.
Very good. The 100 is the whole. So we have our parts are divided up into 100 equal parts. Of that, 20 are green. How would I make that a proper fraction? How would I simplify that fraction?
Would be 1 over 5.
Very, very good. 1 over 5. Essentially, we simplify that down to 1 over 5. But our original 20 over 100, let's say I want to make that a percent, or per 100, per 100. How would I write that as a percentage?
20%.
20%, because it's pretty much the exact same thing. 20 parts of 100, right? Alright, now we're going to go back to our little method we used before. I'm going to put my big 0 down here, and we're going to decide how to write that as a decimal. So, in my 20%, how many tenths of a percent do I have?
2.
2. Very good. And how many 1/100ths of a percent do I have?
0.
0. So I have a total of 0.20 is how I would write that as a decimal. So now I can do math with this. I could like add up all my other ones, my red ones, my blue ones, or whatever, and see exactly how much each of them is worth so we could divide them up together, right? Now, that brings us to what we're going to do today as a class. I have groups of these, and this one will be out of 99 out of 100, so I owe you another sweetheart. Groups of these that you guys are going to break up into your small groups, and you're going to count them out. And I want you to represent for me how many of green, purple, orange, and yellow there are. You're going to write that down in your math notebooks, and then I want you to write each as a fraction, as a percentage, and as a decimal. Then to make things really fun, you guys are going to divide them up among your group fairly. Any questions on how we're going to be doing that?
No.
All right. Well, let's go to our small groups then, and we'll meet back here in just a few minutes to see how everything